everyone, welcome to the video lectures of subject switchgear and protection. We already started the fourth unit, protection of alternator and transformer, and in that we have started the first point, protection of alternator. So in that we have covered the various faults, and secondly that is 4.2, different types of protections used for the alternator. So different faults which can occur on the alternator are, so these are the some faults which can occur on the alternator. So first is the failure of prime mover. So when the input to the prime mover fails, the alternator runs as a synchronous motor and draws some current from the supply system, and this motoring condition is known as the inverted running. So first fault is the failure of prime mover. When the prime mover fails, in that condition is known as the inverted running conditions. So failure of prime mover is the major reason for the faults on the alternator. Then second is the failure of field. So the chances of field failure on the alternators are very rare, and if does not occur, no damage to the no damage will be caused to the alternator and to run without the field for the short period. So this is the failure of field. Then third is the overcurrent. So overcurrents are mainly occur due to the partial breakdown of winding insulation or due to the overload on the supply. So overcurrent protection for the alternator is considered unnecessary because of the some reasons are there for the, that is the some alternators are designed with high internal impedance so that they will stand for the complete short circuit at their terminals for the sufficient time. And second is the overload protection for alternator is such that the protection might disconnect the alternator from the power plant bus on account of some troubles outside the plant. So these are the some reasons failure of the overcurrent, but main reason for the overcurrent is the partial breakdown and the overloading of the and the overload. Then third is the overspeed. So the chief cause of the overspeed is the sudden loss of all the part of the load on the alternator. ओव्हरस्पीड मेन रिझन काय असेल तर जो मेन लोड आहे ओव्हरस्पीडचं काय असेल तर सडन लॉस होत असेल मेजर पार्ट ऑफ द लोडवरचा, तर त्या कंडिशनला आपण ओव्हरस्पीड होऊ शकते. Then next is the over voltage. So the field excitation system of the modern alternator is so designed that the over voltage condition at normal running speed cannot occur, but over voltage in an alternator occurs when the speed of the prime mover increases due to the sudden loss of the alternator load. So main cause is nothing but the speed of the prime mover increases due to the sudden loss is the over voltage. Then unbalanced loading. Unbalanced loading means that there are different phase currents in the alternator. So this is the main cause. Then and last important is the stator winding faults. So the stator winding faults are the most dangerous and likely to cause the considerable damage to the expensive machinery. So the stator winding faults in that fault between the phase and ground, then fault between phases, and interturn faults involving the turn of the same phase winding. So out of this, the stator winding faults is the most dangerous faults which can cause the serious damage to the alternator. So we have so these are the some different faults which can occur on the alternator. So we have to provide the alternator against these faults. So there are different types of protections are used. In that we have covered the first protection, that is the differential protection of the alternator. Then secondly we covered the overheating protection, that is the protection against overheating. In that two methods are used, that is by monitoring the inlet and outlet temperature of the cooling medium, and second is the by using the RTD means resistance temperature detector. So these two methods used for the overheating, that is first is the by monitoring the inlet and outlet temperature, and second is the by using the RTD. So these two different protections we have seen used for the protection of the alternator. Now third type of protection is the balanced earth fault protection, or it is also called as the restricted earth fault protection. So we have to protect the alternator against the earth fault. So the balanced earth fault protection is used. The balanced earth fault protection scheme is mainly used for protection of the small generator where a differential and self-balanced protection systems are not applicable. In a small generator, the neutral end of the three-phase winding is connected internally to a single terminal so that neutral end is not available and protection against earth fault is provided by using the balanced earth fault protection scheme. So such a scheme does not provide protections against phase-to-phase fault until and unless they develop into the earth faults. So third type of protection is the balanced earth fault protection, or it is also called as the restricted earth fault protection. So balanced earth fault protection असेल हे मेनली आपण यूज करतोय प्रोटेक्शन ऑफ द स्मॉल अल्टरनेटरसाठी. कधी तर त्या ठिकाणी डिफरन्शियल आणि सेल्फ बॅलन्स्ड प्रोटेक्शन सिस्टीम्स जर ॲप्लिकेबल नसतील तर त्या कंडिशनला. इन केस ऑफ स्मॉल जनरेटर, जे स्मॉल जनरेटर्स आहेत त्याच्यामध्ये तर न्यूट्रल एंड ऑफ द थ्री फेज वाइंडिंग, जो न्यूट्रल पॉईंट असेल थ्री फेज वाइंडिंगचा इज कनेक्टेड इंटरनली टू द सिंगल टर्मिनल. आपण सिंगल टर्मिनलला तो काय केलेला असेल, कनेक्ट केलेला असेल आणि ते न्यूट्रल एंड सो द कनेक्ट केलेलं असल्यामुळे काय होणार आहे, न्यूट्रल एंड काय नसणार आहे, अवेलेबल नसेल आणि त्याच्यामुळे प्रोटेक्शन अगेन्स्ट अर्थ फॉल्ट इज प्रोव्हाइडेड बाय युझिंग द बॅलन्स्ड अर्थ फॉल्ट प्रोटेक्शन. आणि हे प्रोटेक्शन जसं नेम इंडिकेट करतं आहे की विल बी ॲप्लिकेबल ओनली फॉर द अर्थ प्रोटेक्शन, म्हणजेच हा अर्थ फॉल्टलाच फक्त काय देईल, प्रोटेक्शन देईल. फेस टू फेस फॉल्टला देणार नाही. फेस टू फेस फॉल्टला देईल कधी, ज्यावेळी तो फेस टू फेस फॉल्ट विल बी कन्वर्टेड इन टू द अर्थ फॉल्ट, त्या कंडिशनलाच तो काय करेल, त्याला प्रोटेक्शन प्रोव्हाइड करेल. म्हणजे सिम्पली नेम इंडिकेट्स अर्थ फॉल्ट, सो इट विल गिव्ह द प्रोटेक्शन टू द ओनली अर्थ फॉल्ट प्रोटेक्शन. Since it is also called as the restricted earth fault protection, it will be restricted to give the protection against the earth fault. So it is also called as the restricted earth fault protection. So we see how the balanced earth fault protection scheme will work. So here is the circuit diagram arrangement for the providing the balanced earth fault protection. So in this scheme the current transformer are mounted on each phase. So here two sets of CTs, that is the CT1 current transformer 1 and CT2 current transformer 2. So in CT1 that is current transformer, it will be connected in neutral point, and CT2 it will be connected, that is three set of CTs, CT2 connected in each phase, that is R, Y and B. So three sets of CTs are connected in R, Y, B phase, and one set of CT is connected in neutral and the earth wire. So their secondary is connected in parallel with that of the CT mounted on the conductor joining on the star point of the generator to the earth. So here is the CT secondaries, that means CT secondaries are connected in parallel with, these CT secondaries are connected in parallel with CT secondaries जो set असेल फर्स्टचा connected in parallel with CT1, and a relay is connected across the secondaries of the CT. आणि एक relay, so here is the relay, a relay is connected in parallel with the CT secondaries. ह्या दोन CT secondaryच्या parallel मध्ये आपण काय केलेलं आहे, एक relay यूज केलेला आहे. The balanced protection scheme provide protections against earth fault in the limited region between the neutral and line CT's current transformer. So it provides the protection against the stator winding of the earth fault in the stator and does not operate in case of an external earth fault. So this scheme is also called restricted earthfall protection scheme, and such type of protection is provided in the large generator as an additional protection scheme. So here are the as its name indicates, it will give protection against the earth fault. So here two set of cities, that is city 1, city 2 are used. Here is the generator. We have to protect the generator against the earth fault. So city 1 is connected to the neutral and the earth point, and city set 2, that is city current transformer set 2 is connected in each phase, that is the R, Y and P, and these city secondaries are connected in parallel with the city 1, and across the secondaries of city a relay circuit is used, and the trip circuit is here. So as the this relay coil is energized, the contacts are closed and it will give signal to the circuit breaker for its operation. So this is the constructional details of the generator. We have to provide the generator against the earth fault. Now we see how this system will work. So when the generator is in normal operating condition, the sum of the currents flow in the secondary of the current transformer is 0, and the current flow into the secondary of neutral is also 0. So we have to see the how this system will work. So as we have discussed in the construction, that is the two set of cities are connected in parallel, and across that cities one relay coil is connected. So during normal condition we have to see the operation in that. First is normal condition and second is the fault condition. So during the normal condition, the sum of the currents flow in the secondary of the current transformer is 0, and the current flow into the secondary of the neutral is also 0. नॉर्मल कंडिशन असेल त्या कंडिशनला काय असणार आहे, सिटी सेकंडरीचे करंट सेम रेटिंगचे सिटी यूज केल्यामुळे सिटी सेकंडरीचे जे करंट्स असतील ते सेम असतील, म्हणजेच काय असणार आहे 0. जो सम असणार आहे ती काय असेल 0 असेल. म्हणजे इथून येणारा 0 सिटी 1 पासून येणार 0 जर फ्लो होत असेल तर काय होणार आहे, रिले कॉईल काय होणार नाही, एनर्जाइज होणार नाही. कधी नॉर्मल कंडिशन असेल त्या कंडिशनला. सो द रिले रिमेन्स डी एनर्जाइज्ड. रिले कॉईलमधून जर करंटच फ्लो होणार नसेल तर तो काय होईल, डी एनर्जाइज्ड होणार आहे. म्हणजे नॉर्मल कंडिशनला सिटी सेकंडरीतला करंट सुद्धा काय असेल, दोन्हीमधला 0 असेल, इक्वल असेल. Now suppose when the fault occurs, so when the fault occurs in the protected zone, suppose here is the fault occurs at phase B, that is the earth fault occurs on phase B, then the fault current flow through the primary of the current transformer and the corresponding secondary current will flow through the relay which trips the circuit breaker. So simple, when the fault occurs on phase B, the here some amount of current will flow to the city secondary, and this current will flow through the, as these relay are connected across these two city secondaries, since these current flow through the relay coils, and when the current flows to the relay coil gets energized, and when it is get energized the contacts are closed and it will send signal to the circuit breaker for its operation. So this is the operation against the earth fault when the earth fault occurs on the phase B. So when the earth fault occurs on phase B, some amount of current will flow to the city secondary. Since the relay coil are connected across the city secondary, relay coil gets energized and it will send signal to the circuit breaker for its operation. So but when the fault develops external to the protective zone, that is the right of the current transformer, जो करंट ट्रान्सफॉर्मर असेल त्याच्या राईट साईडला, म्हणजे एक्सटर्नल जर होत असेल तर सम ऑफ द करंट्स ॲट द टर्मिनल ऑफ द जनरेटर इज एक्झॅक्टली इक्वल टू द करंट, इज हेन्स नो करंट फ्लोज द रिले ऑपरेटिंग कॉईल. सो जो आपण इंट्रोडक्शनमध्ये बघितले की बॅलन्स्ड अर्थ फॉल्ट प्रोटेक्शनलाच आपण रिस्ट्रिक्टेड अर्थ फॉल्ट म्हणतोय. रिस्ट्रिक्टेड पोर्शनमध्ये जर फॉल्ट होत असेल तर त्याच्या अगेन्स्ट प्रोटेक्शन प्रोव्हाइड करण्याचं काम कोण करत असेल, हा रिले करत. रिस्ट्रिक्टेड म्हणजेच काय असेल तर दोन फॉल्ट आहेत, सपोज हिअर F1 अँड हिअर इज द F2, हे दोन फॉल्ट ऑकर होत असेल तर जो आता आपण बघितला की सपोज F1 ला जर फॉल्ट क्रिएट होत असेल तर सिटी सेकंडरी काय होईल, ऑपरेट होत असेल. दॅट इज इंटरनल झाला हा इंटरनलमध्ये. बट एक्सटर्नल म्हणजे ह्या साईडला F2 साईडला जर फॉल्ट होत असेल तर त्या कंडिशनला काय होणार नाही, हा रिले प्रोटेक्शन प्रोव्हाइड करणार नाही. म्हणजेच रिस्ट्रिक्टेड पोर्शनमध्येच तो काय करेल, फक्त ऑपरेट करेल. तर हा मिनिंग असेल की रिस्ट्रिक्टेड अर्थ फॉल्ट प्रोटेक्शन म्हणजे काय असेल तर F1ला जर फॉल्ट होत असेल तर ऑपरेट होईल, F2ला फॉल्ट होत असेल तर ऑपरेट होणार नाही. So this is the constructional details and the working. It has some drawbacks. So if the fault occurs near the neutral terminal or when grounding of the neutral is connected through a resistance or a distributing transformer, then the magnitude of the fault current flow through the secondary of the CT becomes small, and this current is less than the pickup current of the relay. Thus, the relay remains inoperative and the fault current continues to persist in the generator winding, which may be highly undesirable. एक ड्रॉबॅक आहे सिस्टीममध्ये तर काय असेल, इफ द फॉल्ट ऑकर्स नियर द न्यूट्रल टर्मिनल, म्हणजे जो न्यूट्रल पॉईंट आहे आपला, न्यूट्रल टर्मिनलला जर फॉल्ट ऑकर्स होत असेल, ऑर व्हेन द ग्राउंडिंग ऑफ द न्यूट्रल इज कनेक्टेड थ्रू ए रेझिस्टन्स, म्हणजे हे न्यूट्रल पॉईंट असेल, हे ग्राउंडिंग असेल, ह्या रेझिस्टन्सनं जर कनेक्शन करत असेल, ऑर ए डिस्ट्रीब्युटिंग ट्रान्सफॉर्मर, then the magnitude of the fault current flow through the secondary of the current transformer becomes small. म्हणजेच काय दिलेलं आहे, सपोज जर फॉल्ट ऑकर होत असेल न्यूट्रल पॉईंटला, तर ह्याच्या सिटी सेकंडरीमधून जाणारा जो करंट असेल तो काय असेल, स्मॉल असेल. आणि तो स्मॉल करंट जर पिकअप व्हॅल्यूपेक्षा जरी कमी असेल, तर पिकअप व्हॅल्यूपेक्षा जर कमी असेल म्हणजेच सपोज पिकअप व्हॅल्यू आपली 5 एम्पियर आहे, 5 एम्पियर जर असेल तर त्या कंडिशनला काय होईल, रिले कॉईल एनर्जाइज होईल आणि इट विल गिव्ह सेंट सिग्नल. सपोज जो फॉल्ट इथं झाल्यानंतरची जर व्हॅल्यू 4 एम्पियर असेल तर पिकअप व्हॅल्यूपेक्षा ती व्हॅल्यू काय झाली, कमी झाली. म्हणजे जरी करंट रिले कॉईलमधून 4 एम्पियर करंट जरी फ्लो होत असेल तर त्या कंडिशनला रिले कॉईल काय होणार नाही, एनर्जाइज होणार नाही. का होणार नाही, रिले कॉईल्स एनर्जाइज होणार नाही म्हणजे काय असेल, जी पिकअप व्हॅल्यू आहे एनर्जाइज होण्यासाठीची ती आहे 5 एम्पियर आणि जो आपला करंट फ्लो होतोय तो 4 एम्पियर आहे. त्याच्यामुळे तो काय होणार नाही, रिले कॉईल एनर्जाइज होणार नाही. आणि जरी फॉल्ट झालेला असेल तरी काय होणार नाही, इट विल नॉट सेंड सिग्नल टू द सर्किट ब्रेकर. म्हणजे हा एक ड्रॉबॅक असेल कधी जर फॉल्ट नियर टू द न्यूट्रल असेल किंवा अर्थिंग रेजिस्टन्सच्या नियर असेल तर त्या कंडिशनला हा काय असेल, एक ड्रॉबॅक असेल. सो दिस इज द थर्ड टाइप ऑफ प्रोटेक्शन, दॅट इज द balanced earth fault protection, or it is also called as the restricted earth fault protection. Since it gives the protection to the restricted area only, it is also called as the restricted earth fault protection. So this is the constructional details. Then working of the balanced earth fault relay. And here is the drawback that we'll discuss that we have discussed, that is the if fault occurs near the neutral terminal, then the CT secondary current will be small and it will not be operative. Thus the relay remains inoperative and the fault current continues to persist in the generator winding, which is highly undesirable. हे कधी जर न्यूट्रल पॉईंटच्या नियर असेल आणि पिकअप व्हॅल्यूपेक्षा जर कमी करंट फ्लो होत असेल तर त्या कंडिशनला हा काय असेल, ड्रॉबॅक असेल. So this is the third type of protection used for the protection of the alternator. In next lecture we see the interturn protection and the earth fault protection. That is the 2 points are remaining, that is the interturn protection and the reverse power protection in the alternator. So if you have any difficulty regarding this, then you can contact me. Thank you.